Last time we talked about some basic operations you can do with Python. We talked about the different arithmetic operations, right? How we can use the plus and the minus and the equals and parentheses and a lot of other arithmetic operations. And importantly, we learned that the assignment of an operator like a plus sign depends on the object that we're using it on, right? We learned that none of the arithmetic operators are tied to the Python language itself, but rather they're tied to integers or floating point numbers or strings, and a specific operator can have a different effect on an object depending upon what object you're using. And we learned a lot about the print statement and different things you can do with it, like formatting output. We saw a couple of ways to do that. We'll talk about a few more ways to do that today. And we talked about embedding escape sequences into strings to do things like backspace characters and tabs and new line characters. Okay. We learned that print is really just a way to serialize objects. And that is to put them into a string of characters that we can transmit over a network. And that when you're interacting with a Jupyter notebook or a command line, you're sending a stream of information from an input device, like a Jupyter window or like a command line, into Python over your internal network. And Python will do something to that information and report it back somehow. And when it does, it produces another stream of information, possibly to the same device, possibly to another device, but everything has to do with the stream. And print is one way to take maybe a complex object and put it into such a format that it can go over a network of some kind. There's other ways to serialize objects, but print is one of them. Okay, so does anybody have questions about anything we talked about last session, or anything we talked about before that, or anything Python related at all? Okay, well, earlier today I was helping a student out with some of the classwork, and there was a little bit of confusion about it. And I thought I'd show you that really quickly before we got going with today's content. So let me pull this over. Here we go. Let's expand this. Okay, and this was one of the pre-class assignments where we had X, Y, and Z assigned different values, and that the goal was to make X equals 6. And Y equals 60 and Z equals 6. And the thing to do is take 3 different statements and order them properly in order to get the correct output. Now the trick to this is realizing that as soon as you assign a new value to a variable, it loses its old value. So let's make a variable called h, and we can say h equals 7 and then ask it to report h. Okay, now if we update h and we say h equals 9999, and then we ask it to report h again, h is going to reflect the new value. So the trick is trying to juggle x, y, and z such that you don't lose any information by reassigning a variable and overwriting its value. All right. Now I did it kind of by trial and error. I just did it switching one thing at a time because there's only 3 possible, or actually maybe 6 possible answers, and was able to figure this out. And as I did so, I applied one of the things you can do with a print statement. this is just to guide my efforts. I said print, and then I made one of these F strings. So it's formatted. And if you use a formatted string, you can put the name of a variable in between these curly braces. And as long as Python knows what that value between the curly braces is, it'll print that out. So I did that with X and Y and Z, and that helped guide my development. So when I run this, I get X is 6, Y is 60, and Z is 6. So I know that the solution is line 2, line 3, line 1. Now, to further help my development, I threw in something that we haven't seen before, but you should know about it. Python knows how to do a lot of different kinds of tests on your work. And there's a lot of ways to do tests. And one of them is in a library. And let me just put this library up here. It's called unit test. And another one is called PyTest. And they have all kinds of ways to test assertions about what different values of variables are. Now, these are beyond the scope of the class, but you should know about them. And you can.
Sorry, can you hear me? Yes.
I can hear you.
Okay, so I'm Paula. I'm the one who asked about this problem. I just wanted to say that this is at the end of lesson 2 on the LMS platform, because I don't know if the others are aware of which is this exercise about.
Oh, okay.
Okay. Yeah.
Okay. No.
Thank you for explaining it.
Oh, no worries, Paula. Thanks for asking the question. Oh, that's okay. There's nothing here that will hurt anybody to know. Okay, so in a real easy way to make tests, and this is stuff that you can just do without having to import or learn new libraries, is Python has an assert statement. And the assert statement just makes a claim. Here we're saying that X is the same as 6 and Y is the same as 60. And each of these assert statements operates independently. But if you say, I'll put it in another cell here, if you assert that 1 is the same as 1, well, that's obviously a true statement. Nothing happens, which is really cool. Because if the result of your hard won code is this result, you've got a real objective way to determine whether it is as expected. And if it is, it just goes through silently. Now, if you made a statement like 1 is the same as 2, you'll get an assertion error. It's not a big error. It doesn't take up a lot of space, but it yells at you. And it says, dude, you missed it. Okay. So they're real easy and cheap to add. And you can implement them easily. The claim you're making can be as complicated as you want it to be. But here it's just real simple because we have a simple problem. So anyway, that's the assert statement and how to use it. And I will just copy this into today's class notes. Oop. We'll copy that. And we'll put it into the class notes here. So, and this will be yours for all time. Okay, so today's class is gonna talk a little bit more about the print statement, but its focus is going to be more on Boolean operations. And Boolean operations are ones that have to do with expressions that involve true or false. They might be literally the Python true and false objects. They could be objects that will evaluate as true or false, or they might be combining true and false values, however you got them, into complicated expressions that will generally, not always, yield a true or false answer. There's a few different operations you can apply to Boolean expressions. Like you can negate them, and you can use the expression and. You can use the expression or. And we'll talk a little bit about how the interpreter evaluates them in terms of what's the most important. We'll talk a little bit more about strings, and we'll talk about indexing and slicing. And that's how do you take a string or any kind of an iterable object, it doesn't matter. Slicing all works the same. How do you take a bit out of it? So if you have like a big word, how do you take out the first bit of it or the last bit of it? Okay, and then we'll talk a little bit more about formatting. Last time we talked about how you can make a print statement and separate arguments with commas, and you can embed spaces or punctuation or whatever you want. We talked a little bit about using an F string to format it in line. And we'll talk a little bit more about some other flavors of formatting. Okay, is everybody good with that? Okay, and just as an overview, and I'll show you all this stuff in code, we'll talk about the Boolean expressions and or not, and how you might use them. We'll look at the priority order and how you can use that even with complicated expressions, like some of them. Okay, we'll talk about slicing, how you can get you can take something like a string like orange and take little bits out of it, like so. This looks like gobbledygook right now, I know, but it'll be really clear to you by the time we're done. Okay. And here's some like a little bit better of an explanation of how this stuff works under the hood. Okay, and finally we'll look at some, or not finally, next we'll look at some string formatting. We've seen how some of this stuff works already. We'll show you some more examples of that. Okay. And lastly, we'll talk about how you can make really complicated expressions like this based only on inputs that are in variables. So if you have a name and value combination, you can inject it with formatting to create really nice expressions like that you might include in some kind of a report. Okay then. So let's have a look at some of these expressions, starting with and then or, and then not. So let's get rid of this and write some real code. So here we'll call this Boolean expressions. Okay, so these guys are all keywords. Okay. And keywords mean that they're built into Python's real basic vocabulary of expressions. And the keywords are the only parts of Python that have to be in English. Everything else can be in the language of your choice. And you can assign any name of your choosing to anything that Python knows about. And a real simple example would be saying something like uno is one. So, which is a Spanish version of it. And you can even do that with a print statement. So you can say escribe, let's say we can say escribar equals print, like so. Okay, and then we can say escribar uno, and we'll print one. But we can't do that with any of the keyword expressions here. Okay, so these are safe, but they have to be in English. Okay, so what and means is everything that you're evaluating has to individually evaluate as true. So the real simple example of that is you can say true and true. Okay, so if everything you're evaluating, in that case, instances of true is true, you'll get a true evaluation from it. And these expressions can be as complicated as you want. Doesn't have to be pairwise. Okay, however, if you get even a single false in here, the whole expression turns into false. Okay, so if you're saying and, it's pretty rigid in terms of what it evaluates. Here we'll just say and we'll make this a markdown cell. Okay, so does everybody see that? So you're saying it's got to be the whole enchilada, and I'll even put that here. That's actually an English expression stolen from Spanish. That means everything. Everything has to be true. Okay, now this is the real simple example of that. Now, you should know that a lot of things will evaluate to be true. Now we're getting a little ahead of ourselves, but we can make an if statement, a quick logical test in Python by using the keyword if, and then something that will evaluate true or false, and then a colon, and then some indented sweep. Of expressions. All right, so the if statement is real super simple. So we can say something like if true, then we can print yay. Now true is always true. It is tautologically true. All right, but we can also put in other kinds of expressions. So we can say if one, print yay, and one will be accepted as true. It'll evaluate as true, and two will as well. And so will three. And so will minus some big number. Okay, so true will evaluate, or an expression can evaluate as true, and be when it's subjected to a test that requires it. So under the hood, Python kind of does a typecast to true or false when it has to come up with a Boolean evaluation. All right, now the exception is if you try to, let's leave that one here. If you evaluate 0, that's going to evaluate false. We didn't get any printout. Okay, so what evaluates true? Okay, a whole bunch of things. So it can be any non-zero number. Okay, and it can be any, almost any. Yeah, it can be any non-empty object. So this might be a string with anything in it. All right, so if we want to say something like if a string like Quinn the Husky, well, that'll evaluate true because it's a string and it isn't empty. If we want to say if just an empty string like so, it will not evaluate true. All right, so in practice, you might see if there's an expression, like if we wanted to say x equals 1 and y equals 2 and z equals 3, we might say if x and y and z. Okay, we can use the and expression here, and it's going to evaluate those all in a Boolean fashion. Okay, and if we want to add these things together, we'll want to make sure that there's something to add. So this would be a good test before we go ahead and add stuff together. Let's make sure it's going to work. So it did that. What if we now said that z is equal to none? None is something else that will evaluate to false. Okay, so this won't even try to print it, which is a good thing, because if we just didn't make that test and we put this out here outside of the if expression, it's going to blow up in our face, right? It's a type error. That's because Python doesn't know what to do with a plus sign operator to combine a non-object and an integer. So none will always evaluate to be false. All right. And something else I'll show you about the and statement. And this is kind of an important topic, so we'll draw it out. Python is lazy. All right, and it's always lazy. Okay, what do I mean by that? Python doesn't do any more work than it has to. All right, so if you have an expression, like if you want to say if x and y, like so, here you're asserting that both x and y are true, right? And then if they are, you'll go do something. Like you might say x divided by y. All right. Now, you might to apply this as a use case is you might want to have something like a numerator, and you might have it some value, and the denominator is equal to 0. Okay, so you might want to make an expression if denominator, and you can say numerator divided by denominator. Okay. You might also want to say, you might want to also test this expression and numerator over denominator. Now, what does this expression do? Okay, it's got an and statement here. So what it's going to do is it'll evaluate this part, okay, then this part. Right. If it fails on the first part, like if this evaluates to be false, then this whole expression has to be false, right? So it doesn't bother to evaluate the rest of it. So the second part of an expression So the second part of an and expression is conditionally executed. In other words, only if we survive the first test. Right? See, you can use this to your advantage. So in this particular case, we're not going to try to do an impossible operation if we can't do the operation. And you can do that really elegantly using an and expression. So if we execute this, nothing's going to happen. If we now take our denominator and we make it into some reasonable number, like 5, and then run the same test, we'll find it'll pass and it'll print yay. Okay, is that making sense? Okay. Now we've got the or statement. And or it works kind of the same way, but kind of different. What or means is only one of those things has to be true. It's not really a statement, it's an expression. There we go. Okay, so we can say true or false, like this. And if one or the other, if any one of the things tested is true, it passes. And I'm going to put passes in quotes because what I mean by that is evaluates true. So true or false is going to evaluate to be a true statement. False or true will also evaluate to be a true statement because it's one or the other. If both of these are false, neither will evaluate true, and the whole expression will evaluate to be false. Okay, and like the and expression, these expressions can be arbitrarily long, and it'll work out just fine. Okay. It'll also be lazy in that, like, if we have this, let's get this guy again. Okay, so if we put or in here, Python is gonna evaluate just enough of this statement to determine where to make the call. So in other words, if denominator evaluates to be true, it will never evaluate the rest of this stuff. Okay. So this could be a really long expression. And if you want to be a little bit efficient, you can put the stuff that's likely to evaluate true in front. The order isn't going to matter usually. You can put it in front, and as soon as Python makes a decision, it's done. All right, so in this case, it's going to evaluate the denominator to be true. So Python is going to say, okay, this whole thing is true. And it will not evaluate this bit of it. Oh, wait, hang on. Okay, yeah, sorry. It evaluated this to be false, so it had to evaluate, right? So it couldn't quit here. That's really what I meant to say. So we can't quit on a bad denominator. And we're going to go get our zero division error. Okay, so that's lazy evaluation. You don't have to memorize truth tables, but here is a truth table if you want one. Okay, and this goes over what it is I just told you. But you know how to make your own truth table now, and if you need help remembering it, there's no better way to remember it than write yourself a little Python script to prove it out. Okay. Priority. We haven't talked about not yet. Let's talk about not just a little bit. But not does probably about what you think it does. What it negates a logical expression. Okay, so we'll call this the not expression. Okay, and all it does is negates. All right, so you can say true, like so, and that's obviously going to be true. Not true is going to be the opposite of that. It just flips it. So not true is going to be false. False is going to be false. And not false is going to be, you guessed it, true. So all it does is flips things. These can be more complicated expressions. So you could say something like not numerator or denominator, like so. And Python will make this determination within the parentheses of numerator or denominator. And just so your notes will be better, let me copy these down here. Okay, so numerator or denominator, well, the numerator is going to evaluate to be true. So this parenthetical expression, or this stuff in between parentheses, is going to evaluate true. And then we'll say not true. And with any luck at all, this is going to report false. Yay, false. All right. So the complexity of the expression that you put the and or not expressions against, it doesn't matter. They all work the same. And if you try to apply one of these, Python under the hood will do its best to make a conversion of the object that you're doing a comparison with into a Boolean object that it can evaluate with a true and false decision. So it's pretty simple stuff. Now the priority order is not, and then and then or. And I think and or are equal, I think. So this is what my notes say, but these are kind of equivalent. All right. So what that means is that you'll recall that we can have arithmetic expressions, and they also have an order of priority. So if we were to, let me get rid of this again for a sec. So if we had an expression like 1 plus 2 times 3, that's where the priority order is going to come in, right? So Python is going to prioritize multiplication-like operations before addition-like operations. So it's going to evaluate the highlighted bit first and then do the second operation. So with any luck, this should yield 7. Okay. Now the Boolean stuff does roughly the same thing. So if we call this Boolean var, and we said something like false and not true, like so. Okay, not is going to get priority, right? So this bit of the operation is going to happen first. So not true is going to be false. So this is going to evaluate false and false. Which is going to be false. And we can throw this stuff together in any combination. So we can say false or not true. And if we really wanted to get stupid, we could say not true. Okay, so not true is false, right? Not false is true. And we have an or expression. So if either the highlighted bit is true or false is true, this whole thing is going to evaluate true. All right, so you need to pay a lot of attention to that. And I'll say here before I forget is that and I'll just say it here. By all means, use parentheses. Okay. And I'll put this in a heading. Use parentheses if you have any doubt. Okay. And that's to help you, and it's to help your teammates. Okay. So if we wanted to take this expression, which is kind of stupidly complex, and we want to say, well, that's actually false or true, and true. We might want to put parentheses in here, even if we don't need them. All right, logically. And the reason is that you have to read this code, and your colleagues have to read this code. And it'd be sure nice if it made sense, right? And it would be sure nice if it made sense without having to put any comments. So don't hesitate to use parens. They don't cost anything. and they can save you a lot in terms of human time and pain to try to figure out what your code means. Okay, so here's another expression that cries for parentheses. So this is true and false or not, false or false. I mean, if anybody worked for me and wrote that line of code, I'd sick my dog on them. But you can see how it's, if you know the order of precedent, you can see how it has to work. So the not gets priority. So not false gets evaluated. Okay, that's going to become true. And Python's going to do that before it does anything else. Okay, now it's going to evaluate this and expression. Okay, so true and false. And it's going to boil that down into false. Okay, so we're able to take our first two operations and they're consolidated here. We haven't dealt with this last false yet. We've just kind of dealt with the higher priority operations. So we've got everything distilled into false or true or false. Okay, so we only need one thing to be true here, right? And we do have at least one thing that's true. So the whole expression has to be true. You can noodle that through, or think it through, I should say. But put in parens. Okay. Does anybody have questions about how that stuff works? Okay. Okay. And if you ever do have expressions like this, don't be afraid to use those assert statements either. Break it down a little at a time. And if you really, really, really need an expression like this, and you probably never will, consider not only using parens, but breaking it down into a couple of expressions, right? There's a certain ethic in Python that you want to have your code really compact. It's called Pythonic. But there's also an ethic that you want it readable. So you might consider, breaking this up into it and calling it test 1, and then calling this test 2, and just making a variable called test 1 and a variable called test 2, and then combine them in a test 3. Over the long run, that'll save you a lot. Okay, I see it's about time to go on a break. Let's do that. And we'll come back in 15 minutes at the top of the hour. And I'll answer any questions that you might have at that point. And if not, we will dive into slicing up strings and other iterable objects. So enjoy. Take care. Okay, now I'm going to go off script for just a second, and let me share the screen here. And I'm going to show you something that you might or might not have any use for, but there is a binary version of the logical stuff we've been using. I'll just show it to you so you know it's there. Okay, so you don't have to remember this. It's just going to be somewhere in your notes. So one of Python's keywords is bin, and that stands for binary. Okay, and what that'll do is give you a binary representation of a base 10 number. What does that mean? If you say bin 8, what you get is a number that has the count of 2 to to the third, and then count of 2 to the second, and then the count of 2 to the first. Okay, so if you ask it for bin 8, you'll get, oh, I kind of screwed that up here. We also have the count of 2 to the 0. So the binary version of 8 is we have one of these, which is 2 to the third, which is 8, and 0 of 2 to the second, which would be 4, and 0 of 2 to the 1, which are 2s, and 0 of 2 to the 0s, which are 1s. All right. So if we wanted to say bin 7, we would have one less than that. And actually, let's leave that there for a second. So that gives us 1, 1, 1, right? So which is 1, 4 plus 1, 2, that gives us 6, plus 1, 1, which gives us 7. So it's just another way of representing a number. Well, sometimes you'll see something like bin 7 and 6, which will give you a binary representation where it shows you what a bitwise operation would be. And I'm going to just do this real quick. I'm going to split this screen and show you what bin 6 looks like. Okay, so if you say bin 7 and 6, what it does is it compares the binary version of 7 with the binary version of 6, and it uses an AND operator. Right? This is just like AND, but it operates separately on every element, which means every bit or every binary information unit. So what it does is if you say AND, you're saying you got a 1, a 1, and a 1. And this is our 8, or 7 rather. And then we have a 1, 1, 0. And this is 6. So it compares the first of these, 1 and 1, and it says it's basically true and true, which evaluates to be true. And I'm gonna just do this here. And that's going to evaluate true and false, because it just compares these columns. So it works exactly like the regular AND. And there's versions of this that will operate just like OR, and that's this symbol. And not, which is this symbol. And there's something called XOR, which is this symbol. And this is an exclusive OR. Okay. In other words, it's one or the other, but not both. Okay, so sometimes you'll see this kind of thing, and these are used for doing things like IP address masking, which is all about comparing binary representations of internet addresses with each other, and you can do things like AND operations to figure out what a valid address is within a range. And if you want to play with it, you can do an exclusive OR on binary versions of text. And it's a really cheap and sleazy way to encrypt stuff. Not for the ages, and anybody can break it, but you can turn easy text or numbers into complete gibberish. So if your boss walks by, they're not going to know what you're doing. So anyway, just, you know, there's binary, and these are called bitwise operations. Sorry, I'm experiencing some latency here. Okay. And these are called bitwise. There we go. It's called bitwise operations. So you might see something or hear something like bitwise and that's what they're talking about. Okay, so let us now shift topics into indexing strings or indexing iterable objects. Give ourselves a little room here. All right. So if you have a string of something, and we can just call this S for a minute, and you want some parts out of it, you can see something like S equals, or sorry, don't even have to say equals. You can ask for part of that string, and you'll see expressions something like this. All right. And what that's going to do is it's going to pull something out of that string. Or you might say something like S, like that. All right. And this looks kind of horrible, and it kind of is, but I think you'll appreciate it as being really elegant. So to show you how this works, I'm going to make a string called S, and the string is going to be numbers. Okay, and that'll make it easy to see what we're doing. So we just ask it for, we can ask it to print S and the type of S. That'll tell us we've got a string, and it shows us what it is. Now the syntax for creating a slice, and this is called a slice, is you use square braces and you give it a parameter. Where are we going to start? Okay. And then a colon. And where are we going to stop? And a colon. And it's called a stride. And that is how many do we skip between the values that we report. All right. Now these all have defaults. So it's really start equals 0. Okay. And stop means the end, and stride equals 1. All right. So if you don't want to provide any of these arguments, these are like keyword arguments, the kind you saw in the print statement. Like with print, you didn't have to provide a separator or an and equals. You could just use the defaults. So if you wanted to say let's see. So using defaults, you could say something like S. Oops, sorry. Say S. That's using defaults. Okay, so you're putting the colons in here, and you're asking it to begin at the beginning and stop at the end and take a stride of 1, which means you start at the beginning of the string and you report every value. Okay, so this is start is 0, and or stop is the end, and the stride is 1. Okay. Now, if you don't provide a value, you can say S and just put 1 colon in here, and that's essentially providing no value. This is the default for start and stop, and nothing for the stride. And that does the same thing. That'll report every value because it's just another way of saying all the defaults. All right. Now, if we want to play around with the beginning, we can ask it for S, and we can say the 0th element. Okay, so implicitly, we're taking the defaults. All right, we're in this case, we're overriding the defaults for everything. Okay, and we're just asking for a single element. If we want the second element, these are all 0 indexed. This will give us 1, and so on. Right. Now, if we want to play with the end of it, we can say S, and then we'll accept the default for the beginning, and we'll ask it to go, we'll set the end to be 2. Okay, so this says the start is 0, and the end is, okay, now this gets tricky. Because this is sort of like if you ever went to a casino and you're playing blackjack, they give you a card and they ask you to insert it somewhere in the deck, and that all the cards before that point are what's going to get cut. So this actually, the 2 here is 1 position past what you want returned. All right. So let's ask it for S again, just so we can see it. So if we're asking for S starting at the beginning, we're going to start at 0, and then we'll have position 1, and we're asking it to stop right before position 2. So we're going to expect this to return the beginning all the way up to right before 2. Let's see if I'm right. Yeah. Okay. So if we wanted to get all the information until right before position 9, we could say the same thing, except we could ask it to go right before position 9. And that should get everything up to 8. Okay, see how that works? So the start is always going to be what you want it to. But the end, you have to specify one past what you want it to be. All right. Now we can play with beginning with start and stop. So we can override more than one default. So we can say S, and we can start it at position 2. And start is going to be pretty exactly what you specify. Then we can ask it to go one position before 9. Right, so that's going to give us this, except for we're going to override the start point. So we should have 2 to 8 coming out of it. See how that works? All right, now we can also play with start and stop and the stride. The stride, you remember, is just how many it skips. So if we wanted to go from 2 to 9 and ask it for every other element of this list, this will work because the default is 1. Okay. So here we skipped every other character. We have only even numbers. If we wanted to get every odd number out of it, or some of the numbers out of it, we could ask it to start at an odd point, and it'll report only odd numbers. And it doesn't care what stride length you give it. It'll just skip that many. So we're not going to get very many at all if we just say S and we accept the defaults for the stop and the start, and then we say the stride length is 5 or 4. And I should label this play with stride only. All right. See how that works? Okay. Now our string, you recall, is immutable. This has any of the elements of it, right? So we can take a bit of the string and we can do all kinds of interesting things with it. So we can say something like the string, and let's just take the even numbers to 8, okay, and then we can add it to the string with string with the odd numbers, or a few of the odd numbers, and see what works. All right, so you can do pretty complicated back-end things with the results of string slices. All right. Another thing you want to know about here is negative indices. You can do all kinds of things with these indices, and they don't have to be exactly intuitive. And here's one of them. If you wanted to say S, okay, and you wanted to take everything and you wanted to do a negative stride, what do you think it would do? You're right. It would do them completely backward, because our default stride is +1. So a negative stride just goes from the beginning to the end, or the end to the beginning, and it goes backward. Okay. If you wanted to ask it for the last, you'll see this a lot. The last element of the string, you can do a -1. All right. If you wanted to go if you wanted to start at the beginning and go to the second from last, you could do something like this. All right, see how that works? So anytime you see a negative here in the last thing, you're just going backward. You can say s -4 and get the fourth from the last. Okay, you can go s -4, and then if you don't put anything here, you'll go to the end. So this goes from fourth to the end. All right, flexibility. Is that all clear as mud now? Okay. And we'll go through a few more examples on some more sensible text, but you'll see this sometimes, and you don't have to know it right now. It's a little bit beyond scope, but there's a slice object known to Python. Okay, and if you said slice, and you ask it for I'm going to get rid of this. I'm going to call it slice, sy. Okay, it reports itself as a slice object. Right. So this is a null slice object, and it's the same thing as this. You can get a little bit more creative, and if you wanted to say slice and you wanted to start at 2 and you wanted to go to 8 and you wanted to skip every other one, that's the same way as saying 2 to 8 and every other one. All right. So let's look at S again. And if we said we wanted to go from S and we're going to do a slice from 2 to 8 to 2, okay, that would start at 2. It would stop 1 before 8. So it would normally stop at 7, and we'll do every other one. Okay, we could also say S, and we could apply our slice object, and it'll do the same thing. What? Hang on. I think we maybe didn't execute that one. Okay, so we can use a slice object that we can define like this, just as we would use a numeric slice. Now, if you're working with people that don't really know what this means, you might want to use a slice object. And you can even name the things that go into a slice object. So you could say something like start at is 2 and stop just before is 8 and stride length 2 you could do exactly this, and you could make a slice object of start at, stop just before, and stride length here. And you can just apply your slice as before. If you have data that's coming into you as like a comma separated format, lines of text, you might create a slice to extract the data you want out of it. You might name your slice. So we might call this a data slice or whatever. Right? And you might even put that somewhere in your code, name data slice. And then it can be in a place where if your data source changes or it changes its geometry, you can make your slice change in one and only one place. Anyway, I'm showing you this not because you need this right away, but sometimes you'll see this and just know that it's another way to make a slice into an object. Okay. All right, so let's look at a graphic here. Okay, and this is just stuff we talked about already. Okay, so your string, whatever it is going to be basically a sequence of characters, right? Or your list is going to be a sequence of elements. Or your data frame is going to be a sequence of rows. Anyway, your iterable object is going to be a sequence of something. And it's going to be iterable. And they're all going to have an index. Now, the index value of the first character in Python is going to be 0. And it's going to be index values that increment by 1 until the end of the object. Right. Now, these red numbers right below, we've talked about these a little bit. This is another way to index the same object, right? You can index it from the back, okay? And the last element has a -1 value. The second last has a -2. And the third has a -3. And you can use either the forward moving index or the backward moving index as you would wish. Whatever makes the most sense to you. And this is kind of cool because you never need to know how long your object is or how many elements are in it. If you know you want to grab the last 3 chunks of it, you can just say -3, right? And it doesn't matter if this has 1 million characters in it, you're still grabbing the last 3, okay? And ditto, if you want to grab every other character, you don't care how long the thing is. And if you try to grab every other character and there's nothing to grab, you just won't get anything back. Well, that's okay. All right. So all this makes sense to you. This is how you grab the entire object with a negative stride. You're moving backward through it. Right? If you didn't put anything for this value and you accepted the +1 value, you would iterate through the whole string front to back. Right? So you get almost identical syntax. You can substitute a value for any of the arguments. Okay, start, and here we're saying nothing for the end. And we're saying nothing for the stride. So here we're going to go from -3 to the end with a stride of 1 because we've accepted every other default except for the argument that we provided to it. All right, clear as mud. Okay. So we got another official example that came from your pre-class work. And I will show you some of that. So you had a city. They had a city, and we called it what? Phoenix. All right. So what do you think we'll get? And I'm just going to say C. I'm going to make another name to this same object, just so it's easier to type and easier for you to watch being typed. So let's just say we wanted that, which is the same as saying C, well, two sets of colons, because in either case, we're accepting the default value for the last element reported and for the stride. So these two expressions are equivalent. What do you think we'll get? So I think we should go from element 1, which is this. We should go from H. We should go all the way to the end. Because remember, we've got a zero-based index. That's why I picked S here. It's zero-based, and actually the index values are, what the argument you would give for the start value. But here we'll start at element 1. We should get H to the end. Yay, we did. So what if we asked for this one? Let's eyeball that. Okay, so we're going to start at the beginning. We've taken the default value. And we're going to go to the index value right before 6. So I'm going to just put a little comment in here. And this is going to be 0, 1, 2, 3, 4, 5, 6. So this is going to go right before 6. So I think this is going to go up to the I. And it's going to start at the beginning. Let's see if that's right. Yes, cool. All right. So what if we said C and we said : 2? That means we're going to begin at the beginning, we're going to end at the end, and we're going to get every other value. So my prediction is going to be, we're going to begin at the beginning, which is going to be P. We're going to skip the H. And then we're going to go O. We'll skip the E, get an N. We'll skip the I, and we'll get an X. See if it works. Yes, okay. So this is just a stride. This tells us we're going to be skipping stuff. All right. Now, how about this one? Let's go from C. So we're going to start at 1. We're going to accept the default for the end. And we're going to skip every other one. What are we going to get? I can see here we're going to start at H, right? Because H is index element 1. And then we're going to go all the way to the end. So we'll just leave everything out, every other one out. So we'll skip the O, we'll get an E, skip the N and get an I. And I think we're done. Yeah. Okay. So how about city -3? Okay. So this means we're going to start at the third from the last, and then we're going to go all the way to the end. And we're going to accept the argument for the stride, which is 1. So I think, well, let's give the Phoenix another index here. And these are going to be neg. Okay. And this is going to be 6, 5, 4, 3, 2, 1, 7, 6. Yeah, okay. So these are all going to be minus. So we start from -3. That should give us the n. Then we'll just go to the end because we don't have any argument here. Let's see what we get. Yeah, okay. So we got the NIX as advertised. Okay. And then finally, let's say C, and we'll say start at the beginning, no argument. Go to the end, no argument, with a -1 stride. Well, we've seen that before, and by striding through it with -1, we're essentially reversing it. All right. Is that making sense? Okay.
Yes, so.
All right. So let's make a new slice. And we can call it a slice. And we can give it a beginning. We have to provide placeholders here. This is another use for none. And we're not going to provide an argument for the end. And we're going to say -1. And we might even call this reverse slice. How about just reverser? Call it a slice. And then we can say city. And then we can say reverser. Now notice our slice object is between square braces, right? We're not calling a function here. We're just using it as a placeholder. And this should give us the same results. Okay. All right, cool. Now, we got a few minutes for a break. Let's just do a mental exercise here. And just in your own head, try to guess what hippopotamus. That's a hell of a big word for people whose English is their second language, but okay. So we got hippopotamus, and see if you can guess just in your own head what this slice operation means. I'm going to make this screen here a little bit smaller so we can look at them side by side. Okay, give some room here. Call this practice. And our animal is going to be equal to hippopotamus. And I'm not going to type that. I'm just going to say A is animal. We haven't changed the object, which is an immutable string. We just give it another name. So in your head, what is A1 colon? Well, here's your answer. Okay. Did anybody not get that? All right, let's try the next one. Okay. So we're going to go from the beginning until, going to set an end index to 6. All right. Now, did anybody say that it was going to be O? That we're going to end here because that's 6. I hope not, because you don't specify the last index point. you identify the one right before that as your specifying the last point. Okay, what's the next one? So we're going to say A. There. Okay, what's that one going to be? Drum roll, and it's bada boom. We got every other letter in hippopotamus. Okay. Next one's a little complicated. Okay, what's that one going to do? Okay, we're going to start with element 1. We're going to go not to 7, but to the one right before 7. So we'll go here. And we'll hit every other character. So we'll skip every other character. So it should go something like IPP. Yeah. All right. So A minus. Okay, here we go. Yes. And finally, let's go A colon minus 1. All right, here we go. Boom. All right. So if any of you guys don't get this yet, by all means, I would encourage you to practice. And I would actually encourage you to practice with this string or something just like it. It's really easy to eyeball, easy to look at, and the indices have some relationship to the content. Because slicing is a very, very, very important concept in Python. And you can't really get that far without having mastered it. And it becomes extremely important once you start getting into data science, when you're doing all kinds of things with high dimension objects. In fact, the slicing extends to two-dimensional spreadsheet-like objects called data frames, and high dimension feature sets when you start playing with machine learning. So don't let this one go by without completely understanding it. And if there's something I haven't explained, please let me know, because outside of getting help learning how to test your code, slicing operations are among the most important thing you'll learn. Okay, and it is again time for a break. So I'll let you.
Are we able to get the PDF version of this Jupyter class notes, download that one, and can someone share with us that as attachment, that we can use all of these practices that you did today and all of these 3 or 4 times,
Yeah, what I've been doing is I've been putting the notebook into the Slack channel, and they all should be there. And right after today's class, I'll put this one into the Slack channel, and I've been using the one called Class Chat.
Okay. Is there a name for that one? Like when you put it there?
It will be, well, the general name for the I don't know how it works. This is called a channel, right? Class Chat, and it's part of the Clarusway tech community.
Yeah. No, I have it. I have it actually in front of me. That's why I'm saying I didn't see it. Yeah, I don't know. Maybe.
Well, that's because the class isn't done. What it's going to be called,
like the previous one as well. All of that. Just practicing.
Oh yeah, just scroll up and you'll get to it. Scroll up in the Slack channel.
Okay.
And this one, and the last one will be called something clever like Class Notes Intro Python 3. If you can't find it, let me know and I'll repost it. Okay, So I'll see you at the top of the hour, and I will retank my coffee so I don't fall asleep and drown myself. I'll see you in a bit. So let's just take our slice, our string S. There's a string method called find. So we can say help str.find. Okay, what find is going to let us do is it's going to let us find a particular string within another string. Okay, and the syntax is just this find. Okay, and it's a method on a string, right? So we can say s.find, and we can give it the thing we want it to find. So let's just ask it to find 4. Now, if it can find 4, if it finds 4, it'll return the index value of 4. Otherwise, it returns a -1. All right. So s.find 4 should return index point 1, 2, 3, 0, 1, 2, 3, 4. Okay. So it should return 4. Okay. So now if we wanted to use a slice on our string, we could use s.find 4 as one of the arguments. Okay, and then we can compose it just like we would normally. So we can tell it where to end, and we can give it a stride length. Okay, or not. So here we'll just, this is going to be the equivalent of saying S4. You see how that works? Or if we wanted to look at our animal and we wanted to say animal, and then we can do a slice operation. We can provide any of these arguments that we want to. We might say go to the beginning and go to wherever we find P. Okay, and if we will actually want, okay, so we can do this. So it's going to come to HI. The index value of P is going to be 0, 1, 2. So this should provide the first 2 characters of animal. Or sorry, let's see. Let's go from the beginning. Hang on. Find P. Oh, you know what? I said s.find. We need animal.find. Okay. Everybody see what that did? When I accidentally said s.find P, it returned a -1 because it couldn't find P in our string of numbers. Right? It couldn't find, P is not in this string. Couldn't find it, returned a -1. So when I said animal, and I asked it to go to s.find P, this is the same as saying animal. Same as saying animal -1. And if I wanted it to go from the beginning to 1 before the end, it would do that. It would leave off this final letter. Does that make sense?
I have a question.
Yes.
Sorry if I missed you explained before, but why when we as find P, because there's nothing to find, output is -1 instead of like syntax error or something?
That's right.
Why it's so?
Why did it return a -1?
Yes.
Oh, that's just the way find works. So we say help. It's just the way this particular command is implemented. Okay, if we read about it, we can say returns the lowest value in S where it's found. So it gives us the index value. Okay, and if it doesn't find it, it returns -1.
Okay, -1 means like wrong or I couldn't find or failure. Okay.
Exactly.
Okay, thank you.
question.
Thank you.
So did that answer the original question? How can you use a slice based on the value of the string? Do you know how to do that now?
Yes, sir. Thank you very much.
Awesome. Good questions. Anything else? These are really good questions. Okay. So we are going to shift topics a little bit, and we're going to talk about, let's see, string formatting. Okay, so there's a few ways we talked about formatting strings so far, and there's a few more. And you can use any kind of way to format strings that you want to. And you'll see all kinds of ways to format strings out there, because as you start using Python more and more, you'll be working with other people. And sometimes you'll be working on old code. And Python has evolved over time. And as it has, the ability to format and process text has increased. And there's been some pretty cool things introduced in the last few iterations of it. Now, there's a difference between Python 2 and Python 3. I'll point out. Let me get rid of this for a second. And let me just do this here. Oh, I don't know what I just did. What did I just do? Okay, so let me make this a markdown cell, and we're going to say more on strings and printing. Okay, now just know this, in Python 2.x, and there's plenty of 2.7 code, it's common. Print was implemented as a statement. Okay, and then you'd print and then you'd say some stuff. Okay, and this is a statement. In Python 3.x, print is implemented as a function. So there's some differences between Python 2 and 3 in terms of how you use print. It's been a part of both. But outside of these differences, most of the print stuff from the old days remains. So that's kind of a long way of saying you'll be seeing a lot of different ways to format strings and to print in the course of your career. So it's kind of good to recognize it when you see it, even if it's not what you choose to use. All right. So let's look at string formatting, because string formatting and printing are mighty close to the same thing. So we'll be talking here about how you can use some of the basic arithmetic operators like equals and plus and star against a string. All right. Now we've seen some of this stuff before. Let me just show you this again. Okay, so we've seen how we can make simple assignation operations. Okay, and we've seen what a plus does. Do you remember what a plus does? Okay, see if you can remember. Okay, so you might have remembered what a plus sign does is concatenation, which is a fancy term for just shoving some stuff together. And that's what the plus sign does against two strings. And all these are going to produce the same output. So here we're making a new name, a variable, and we're using the plus operator. Okay, here we're doing that same operation, but we're doing it to compose an argument to our print function. So these two get combined in the print function to form a single argument. All right, and here we've just used the names instead of the variables. And here in the last one, we've used our new variable that does that combination. So these are all permutations, or they're all different versions of the same thing. Is that clear to everybody? Okay. Now, how about this one? We've seen the star operator before. Do you remember what it does? Yeah, what star does is it just tells you how many of those things put together. Yeah.
It's repeating 3 times. Is it right the same? Like.
Yeah, exactly. Exactly. So here we're just like we looked at with a plus sign operator. We're taking our string and we're making 3 of them. So that's going to say upper, upper, upper. Right. And it doesn't matter what order. It's going to say upper, upper, upper. Okay. Now this you haven't seen before. Okay. This is you know what? I don't know the right name for this, but I think of it in terms of an exploder. What this will do in an input argument to a function, and print is a function, what this will do is it'll take the contents of an iterable object and it'll separate them into individual arguments. And I'll show you what this produces. Okay, now the first 2 should look familiar. The second one looks kind of weird, right? And let me show you just by playing around with some code. So this is rendering kind of weird, isn't it? Let me do something here. Yeah, there we go, much better. Okay. So if we had a, let's see, our example here is upper. So our string is going to be equal upper, like so. And, I don't like the fact that it's, yeah, here we go. That's a little bit better. Okay, so this is an iterable object. It doesn't really matter that it's a string. So if we say print s, we will get what we expect. It'll look much better if we call it a code cell, because then it'll execute as Python code. There we go. So we'll get up or out of it. If we want to say print star s, what that is saying, what the star is going to do is it's going to turn it into print U P P E R. All right, because the exploding operation is going to take this sequence of our iterable object and turn it into its components. And that's why it looks like this, because we've invoked the default separator. Which is an empty string. And we can prove that by taking the same expression here and changing our separator. And we'll just change it into a few of these little bar things. Okay. So that is a way to kind of manipulate any iterable object upon ingestion into any function. So another iterable object, let's make a list. And we can say print list. So, and we've given, what it produces is a string representation of our list object. If we wanted to change this by saying print star list, what it's going to do is it's going to explode all the individual elements of our list, and then it's going to print them just like we did our string. Okay, and to prove that, we can just say our sep equals, give it some star quality here. Okay. Now, another thing you can do is you can use a plus equals together. Okay, remember our plus equals. So you might recall that we've got a lot of compound arguments that we can use. And you know, pretty much every arithmetic operator has a compound version of it. Well, we can do that also with a string, right? So, so we can say A equals, you can pronounce that A in English, and B is equal to B. You can pronounce that B in English, and C is equal to C, which is pronounced C in English. So you can say A plus A. If I could type, we could say A plus A, and we would be putting it together. Or we could say A plus B plus C, right? We've seen how we could print A plus B plus C as an argument, and then we could maybe print C and B and A as separate arguments. So we should get 4 things printed out here, and we do. So this became one argument, or the result of this operation became one argument, and then we could produce more. Well, we could also use the plus equals argument. So if we wanted to say A plus equal B, this is going to be the same as A equals A plus B. Okay. And that's just like saying x equals 3, or 3, and x plus equals 100, which is the same as saying x equals x plus 100. All right, so that'll work the same way as a string, on a string, I should say. Okay. Another thing I will point out, I don't want to over elaborate on this, but if we said x equals some string, and we asked it to produce, let's do a formatted string here, and the ID of x is that, and we'll put the ID of x inside the curly braces, like so. So it'll evaluate and then print. We learned that x lives at this address. Now, if we said x plus equals with another string, like so, and then we ask it again for the ID of x, we'll just copy and paste this down. We'll find that x now lives somewhere else. Okay. And the reason it lives somewhere else is strings are immutable. We can't change them. We can create a new object. So here we created a name called x, and we assigned it to a string object. And Python tucked it into bed and put it here at this address. When we did this operation, we created an object called, that combined our current value of x and a new string. Okay, and we had to reassign it to the name x. So we recycled the name x. We gave it another object, and that object has to live somewhere else because it's a different object. Okay, so strings are immutable, and any kind of an operation that changes the value, including an assignation to add another variable, creates a different object. But it'll act pretty much the way you think. Okay. And here are some more examples of that. Okay, so we got our upper and lower case, and I'll be quiet for a few seconds here and see if you can think of what you're going to get if you perform these operations, and then I'll show you the output. Okay. So the first string 1 is called upper. And now we've said upper is the same as, or sorry, we said string 1 is going to be well, we had it originally, and then we're going to add on case, creating a new object. So you might expect this would say uppercase. Now, if you took that new object, right, it's a brand new object that replaced the original, just like we just saw. We were going to add to it something else, again, creating a new object, right? So we perform two separate objects, creating a new one every time, and we'll do it a last time with end. So what you're going to see is all these values in red, all these strings in red shoved together. Okay. So the two stories to take from here is you're always creating a new object if you're doing a reassignation of a string to the same name. Okay, so you're making it the change to the string is persistent if you do it in this way. Okay, and you can do things stepwise, creating a new object each time. Okay, so here is another way you can format a string, and that's you can use the built-in format method. And the format is a method on the string object. All right, and this is kind of a placeholder replacement, sort of like we saw before with the F string. The F string has largely replaced this, but certainly not everywhere. And there are a lot of people that still use this on new code. But it works the same way. We have these curly brackets and they're a placeholder. And then we can say .format, and we have to give it as many arguments to the format, which is a function or method. We have to give it as many arguments here as we have placeholders. All right. So that is going to look like, show you some real code here. And this is going to be the format method of the string object. I'll just put format in parens here to be a little bit more precise. Okay, so you can, let's get a string, and let's call it dog, and let's call it husky, just for fun. Okay. And we can make a string to format on a print statement. So we can say Pat has a, like so, there's our placeholder. Now if we say .format, we can say dog. And if we spell format correctly, we can actually see our husky. There we go. Pat has a husky. So you can put any kind of characters in here, or any kind of expression, because this is just a string. And the only thing different is we've got a little placeholder thing here. We can have more than one thing. So I've actually got two dogs. My favorite is the husky, of course. My daughter's dog is a corgi, who's kind of cute, but really obnoxious. So we can adjust this to add another argument. And all we have to do here is add two arguments to the format, and it'll put one in each place. Okay. And see, another permutation of this is you can, and this will be real familiar. Let's just say we have we want to print Pat as a dog 1 and a dog 2. So this looks a lot like our F format string, right? And here we can add a dog 1 equals husky. Let's make it a capital husky. And the dog 2 equals a corgi. All right, so that's gonna this is gonna basically introduce a little namespace here. Just like we did up here, we made a name and a value into Python's main namespace. And here we had another name and a value. Well, here we're pairing up the names and the values. Okay, so we're adding that here, and then this namespace is getting interrogated here. So it's going to find a dog 1 and a dog 2. And it's going to add them from the arguments, the format statement. All right. Now, if you do that, you have to be sure to match up the names that you put here and here, because it's going to be pretty specific. So basically, you're making a dictionary with key value pairs. And we looked at a dictionary object a little bit, but that's what you're doing under the hood. And in fact, if let's see, I don't want to screw this up, but I'm going to try it. You can do this. You can make a dictionary like so. Make this differently cased, and you put a colon when you specify a dictionary between the key value pairs. You can say dog 2, and you can say colon corgi. All right, so that's a dictionary, and you can ask it to print itself out, and there's your dictionary. Well, you can say exactly this, and you can give that dictionary to the format like so. And if you want to provide a dictionary to a function, remember we had an exploder earlier where we took a sequence, a string, and we took a list and we exploded it out as different arguments. Well, if you have a dictionary, you can put 2 stars and it'll explode it. It'll explode it into something like this, into the key value pairs. So if you want to use a format statement like this, and you want to make dictionaries on the fly, and maybe have this print statement serve for all kinds of different dictionaries that have dogs in them, you can just have this statement sitting around here and feed it different dictionaries. And this should work. Drum roll. No, it's not happy. Because, oh, I know. Because dog 1, husky, husky, dog 1, husky, dog 2, corgi. Oh, hang on a second. D equals. Oh, I know. We need to put these like this. This will be much happier. Okay. And that'll be much happier. Okay. So here we made a dictionary. We've got a key of dog 1 is a string, and it's associated with the value husky, just like it is here. Okay, and we can feed a dictionary to a format and use the double exploder. Okay, so there's two kinds of exploders in Python. Okay. Now under the hood, these things in the curly braces have numbers. Okay, and they've got index values. And as you might imagine, this is known as 0. And this one is known as 1. All right. And they will index the arguments. So if you want to give this a bunch of arguments, and you might want to say, let's say noble beast. That would be the husky, of course. And the other would be a rat dog. That would be the corgi. Well, we could, oh, it's not happy here. Dog 1, dog 2. And that's because we want to put index values in here. So we want to say index value 0 and index value 1, like so. Right, so it'll treat these things as index values 0 and 1. All right. By default, it'll just stick them in here if they're empty. All right, so we can take this, and we don't have to use every argument that we give it. So we could say, put in a 0 here, and it's going to come here, and it's going to use a 0 index on the arguments we provided to format, and I'm going to get 2 noble beasts, so I don't have to put up with a rat dog. And you can have extra arguments here, and you can call this, I don't know, a pit bull. I don't have a pit bull, but let's say I did. And it'll just ignore the last argument. It doesn't care. So the things you put in your format can be a superset of what you're actually going to use in any particular print statement. All right, now you can do these in any order, right? So if you wanted to reverse these, let's just print all these things out. We want to add an extra thing here. So we want to print them all out. We could do this. If we wanted to reverse the arguments, we could easily do that. So we could say I've got a 2 and a 1 and a 0. And it'll just take those indices from our arguments at the end. Does that make sense? Okay. Yeah, one other thing I want to show you on formatting is this is old. Anytime you see this in English, this is a very old spelling of old time. Well, you'll see this kind of a lot. Back from the days of Fortran, and Python still supports this. I just want to show it to you in case you ever see, if you have a string like so, and you can say my dog's name is, you can put a % and a letter after it. And then if after that you put a % and you say Quinn, so it'll honor that. It'll use this kind of placeholder, and you can also say something like, who is %I years old? Okay, and then here you put a %sign, and then you put delimited arguments here to serve as placeholders. And that'll work just the same. Now, you don't see this very often in modern code, but you'll see plenty of it in legacy code. It's kind of succinct, and the issue here is that the types have to match. So %s means a string, and %I means an integer, and %f means a float, etc. So you can't screw that up. So it's not very flexible. But I'm putting this in here just so if you see it, you'll recognize it. And know that, I mean, you can see it's Python is backward compatible in the handling of this kind of string. And in fact, it's backward compatible handling any kind of string. Where Python isn't backward compatible is print. Okay, so we had a difference between Python 2 and 3 where print used to be a statement and now it's a function. You'll have to honor that if you're writing new code. And there's a few ways around that to bridge that gap. But just know we've got lots of ways to format stuff. The formatting is backward compatible. You may have to use it a little bit different in a print statement. All right. And I want to show you one more time. I realized that I didn't do what I said I was going to do last time. I didn't share the documentation. And formats are nearly infinitely flexible. And if you go to Google Python mini format language, you will find comprehensive and excellent documentation. And just to prove that works, we'll do that here. Okay, and the first thing you see is probably going to be the right documentation. Check the version number, and then come here to custom string formatting, and you can see all the format syntaxes. Okay, and we'll actually take you down one more here. Okay, so we'll save that as part of the documentation here. Okay, check version at top of docs. Okay, and you'll find all the different stuff you can do in terms of printing out binary numbers, changing the precision, putting in any kind of hex values you want or % signs. So it can be anything you want to. And this is where you do the columns and alignments. All right. So I'm going to save that. That's the material I have for you today, which is really good because we're right at the end of our time together.